All right, so we're going to do notes on parallel and perpendicular lines. So you can go ahead and copy all of this down into your spiral notebook so you have the notes written down. Okay, so parallel lines are lines that never intersect, which means they never touch, they never cross each other. And so because they never intersect, these lines have the same slope. So if you're looking at an equation or any of that, if you can find the slope, and if the two equations have the same slope, then those lines are parallel. Now, if we're talking about perpendicular. Perpendicular lines are lines that intersect at a right angle. So that means they cross, but they do more than just cross. They cross at a right angle. And so perpendicular lines have opposite reciprocal slopes. And what that means is that the slopes the sign has changed. So one is positive, one is negative, and the fraction has been flipped. So like 2/3 and 3/2. And then the sign has to be changed. So for lines to be perpendicular, the slopes have to be one positive, one negative, and then the fraction has been flipped. And so, for example, I want to give some examples of opposite reciprocal slopes. So an example of that would be if you had 1/2 as a slope, then the opposite reciprocal would be negative. Now flip the fraction 2/1 or just 2. So these two are opposite reciprocal slopes. If I had a fraction that was negative 3/4, then the opposite reciprocal slope would be change the sign, make it positive, and then flip the fraction. Okay? All right, so let's do some examples on trying to determine if lines are parallel, perpendicular, or if they're not either one of those, then we consider that neither. So let's do some examples. So in these examples, we want to determine if segments A, B, and CD are parallel, perpendicular, or neither. So what information do we need? We need to be able to find the slope. So let's find the slope of AB. And remember, in order to find slope, you subtract the y's over subtract the x's. So for AB, we're going to subtract the y's. So we got 3 minus 6 over, and then subtract the x's, negative 2 minus 2. So 3 minus 6 equals negative 3. And then negative 2 over negative 2 is negative 4. And then so remember, a negative over a negative is positive. So this slope of AB is 3/4. So now let's find the slope of CD. All right, so let's find the slope. We're going to subtract the y's. So we have 0 minus 3 over subtract the x's, negative 1 minus 3. And so now we have 0 minus 3, which is negative 3, and then negative 1 minus 3, which is negative 4. So we have a negative 3 over a negative 4. Remember, that's going to be positive 3/4. So line AB has a slope of 3/4. Line CD has a slope of 3/4, which is the same. So that makes these lines parallel. We can say they are parallel. And the symbol for parallel looks like two parallel lines, or the two L's in parallel. Okay, so that's the symbol for parallel. All right, so let's try example 2. We got AB at 0, 2, and 5, 4, and then CD formed by 1, 8, and 3, 3. So let's go ahead and find the slope of AB. And so the slope of AB, remember, we're going to subtract the y values. So 2 minus 4 divided by subtract the x values, 0 minus 5. So let's simplify. 2 minus 4 is negative 2. Divided by 0 minus 5 is negative 5. So let's simplify that. We get 2/5. All right, so the slope of AB is 2/5. So now let's find the slope of CD. So again, subtract the y's, 8 minus 3 over subtract the x's, 1 minus 3. So 8 minus 3 is 5, and 1 minus 3 is -2. So this is a -5/2. Okay, it doesn't really matter where this negative is. So now, what do we look? We know they're not the same. They have been flipped, and one's positive, one's negative, so these are perpendicular to each other. All right, so we know these are perpendicular. And the symbol for perpendicular looks like a upside down T. All right, so let's try example 3. So now we got to find the slope of AB. So we're going to do 8 minus 6 over -1 minus 2. Oops. So 8 minus 6 is 2 over -1 minus 2 is -3. Can't simplify anymore. So this AB has a slope of -2/3. And then so let's do CD. So we're going to subtract the y values again over subtract the x values. So 2 minus 3 is -1, and -1 minus 3 is -4. And then we simplify that. Negative over negative makes a positive, so this has a slope of 1/4. All right, so AB has a slope of -2/3, CD has a slope of 1/4. They're not the same. They're not opposite reciprocals. So in that case, we say these are neither. All right, so these two are neither. All right, so take a second, pause the video, you do number 4, and then try to determine if they are parallel, perpendicular, or neither. All right, so if you've done AB has a slope of -1/3 and CD has a slope of 3. And so those are opposite reciprocals of each other, so they are perpendicular. So this shows the symbol for perpendicular. Okay. All right, so we're going to do a couple more examples. And these examples that we're going to do are trying to determine if equations of lines are perpendicular. All right, so what if I have the equation y equals 7x plus 2, and sorry about that, and then y is equal to 7x minus 1. Okay, so now we're trying to determine, well, are these lines perpendicular to each other? Or are they parallel, or are they neither? And so what information do we need? We need their slope. So we look here, remember these are in slope-intercept form, so the number sitting in front of the x value is the slope. So in this one, the slope is 7. And over here, the slope is 7. So they have the same slope, so these lines are parallel. Remember, that's the symbol for parallel. All right, let's try another Let's try another one. I don't know why this pen isn't working. All right, so what if we have the equation y is equal to 4/5 x minus 8. And then we have the equation y is equal to negative 5/4 x plus 3. Okay, so what do we need? We need the slope. Excuse me. All right, so if these are our equations, well, now we know that the slope here is 4/5. And then the slope on this one is negative 5/4. So they're not the same, so they're not parallel, but they are opposite reciprocals, so these are perpendicular to each other. So let's try another one. We have y is equal to negative 1/3 x plus 2. And then we have y is equal to just 1/3 x. So again, let's identify the slope. So the slope here is negative 1/3. And then the slope here is a positive 1/3. Well, they're not the same because one's negative and one's positive, so they're not parallel. They're not opposite reciprocals because, yes, they do have different signs, but the fractions haven't been flipped. So in that case, that would make these neither. Okay. All right, let's try another example. So what if we have the equation x plus 6y is equal to 30. And then we have the equation 3y equals 18x minus 6. Well, why are these different than the other three that we've done? It's because these aren't in slope-intercept form. So we can't automatically tell the slope right away, but we do know how to solve and put them in slope-intercept form so we can determine the slope. So for this one, remember we need to subtract x from both sides. So now we have 6y is equal to negative x plus 30. We still don't have y by itself, so we're going to divide everything by 6. Oops, sorry. And then also y is equal to negative 1/6 x plus 5. So here we know our slope is negative 1/6. But we had to solve it first in order to find that one. Now this one, the x term has already been moved. We just need to move the number in front of the y. So we're going to divide everything by 3. Remember, those cancel. So we're left with y equals 6x minus 2. And this one has a slope of positive 6. Now that was in slope-intercept form, we can tell. So now we got a slope of negative 1/6 and we got a slope of 6. They're not the same, so they're not parallel, but they are opposite reciprocals, so that would make them perpendicular to each other. And one more example. What if I had the equation of the line y equals 6? And then what if I had the equation x is equal to negative 1? So we need to figure this out. So y equals 6, if we remember our Hoy-Bucks, an equation that's just y equals has a 0 slope. So this one has a slope of 0. And this one has a slope that is undefined. So we know they're not parallel because they don't have the same slope. And so because it's undefined, it's like, well, what are we doing with this number? But just think about it. If it's a y equals, that means it's a horizontal line. And if it's an x equals, that means it's a vertical line. And these would be perpendicular to each other. So if a line has a zero slope and an undefined slope, that makes them perpendicular. Okay, and then that's it.